Dr. Gurmeet Singh is a professor and a head of the Center for Ayurveda, Biology and Holistic Nutrition at the Trans-Disciplinary University, Bangalore. He is a scientist, inventor and innovator with 25 years of experience in academia and a strong interest in developing sustainable food-first solutions for health and wellness issues. He has a B.Tech in Chemical Engineering from IIT Delhi and a PhD from Pennsylvania State University, USA, and has 25 patents filed and 20 published publications. Let me welcome Dr. Gurmeet Singh to present his paper on blending of botanicals, opportunities for the tea sector.
Yeah, so thanks for inviting me here, and thanks Sridhar, thanks Sanjay ji, thanks Jeffrey, thanks Victor for the initiating the project. I came here about 2 years ago where I talk about processing and innovation around processing. But our university, where I come from, Trans-Disciplinary University, they have an expertise. 30 years they've been researching medicinal plants of India, right? And so this idea came together that let's look at how medicinal plants and tea can go together, right? And therefore, intercropping botanicals in plantations to create infusions of goodness, right? So yeah, I begin here. This is just an acknowledgement of all the people who've contributed to this knowledge, right? This is a slide from 1966, right? A book, a conference which happened in 1966 and a very famous quote. Today, since then, 60 years have passed, and so there are about 91 billion people. So the number is not 90% anymore, it's about 85%. But 85% of all humans born ever were hunter-gatherers. And they have been accumulated a lot of knowledge from that hunting and gathering. And that knowledge is what we are trying to understand. No scientific, no AI, no science endeavor can look at this millions of years of history and come to the kind of knowledge that has been learned from experience by the 85% of all humans born ever since Homo sapiens came to the world, right? Maybe one day, but not in the near future, right? So in India, these local communities, right? How many medicinal plants is a question that comes up. And so far, we've documented through research about 6,500 different species of plants which have been used in medicine, right, all across India. So which systems have been used for? This is a chart which shows that about out of these 6,500, I guess the marker is not working. Yeah? But anyway, about 1,500 or so from Ayurveda, then about 5,000 or so in folk knowledge. So the maximum number is still right in folk knowledge, about homeopathy some, Siddha about 1,000 or so, Swarikpa, which is the Tibetan system, about 250 or so, Unani about 500 or so. So a lot of them codified, Ayurveda, homeopathy, Siddha, Tibetan, they're all codified systems. But folk is something which is still to be codified, right? While they're in practice, but they've not still reached a codified system as of today. So there's a lot of botanical wealth and their uses which are known to us, right? May not necessarily be science-based evidence as we want today, but a lot of it is practice-based evidence, right, which exists. So where do these medicinal plants exist, right? And so we divide India into these biogeographic zones, 10 biogeographic zones, the colored, and then they are subdivided into forest types and biotic provinces, etc. And we can see that they are kind of spread around. And from where we are in UPASI, in the Nilgiris and other ranges, so about 2,000 or so species here. So quite a dense, right, population of plants, yeah, in this region. Of the 6,500, not all are traded, yeah, in today's world. So how many are traded is a big question, and that itself required a lot of research to happen, right? Almost a decade-long research to figure out how many are being traded today. 30 years of research to get to know how many are in use, and another 10 years to figure out how many of them are traded today, right? And so about 1,000 or so are traded, 1,178 have been traded, and this is work that we've done along with the National Medicinal Plant Board and published a book, right? That book itself is now 7, 8 years old, so it's the next version that we need to now work on and update that, right? And so how do we use these, how do we get hold of these 1,000 or so plant species, right? And what this just tells us is just a glimpse of that a lot of these species, 72%, 80% nearly of these are actually gathered, right? Hardly about 200 species out of 1,000 are cultivated, right? The rest are still gathered. And where are they gathered from? Gathered from tropical forests, right? Gathered from roadsides and wastelands, right? And of course, some of those species are cultivated. So what I have here is the highly, right, traded species, right, which are about 200 or so out of the 1,000 that are traded. Yeah. So 11 of those species, which are really high volume, which are, and kind of some numbers, just to give you a context of the kind of plantation sizes, etc., wherever we have, and you may recognize like aloe and pipali and ashwagandha and tulsi and artemisia and vetiver in there. But cultivated area, 180,000 hectares, which is kind of minuscule compared to what tea plantations total, right? And so how do these get to us? So of course, a lot of these are, there are billions of gatherers, as we said, and growers. And through wild collection and cultivation, they come to, those are the primary collectors, right? Then they get to mandis, eventually through thousands of traders, in there. And then get to jadi booty mandis, specialized herbal mandis, cooperative federations, etc. And finally reach through traders to more than 1 million folk healers, right? Dispensing their own self-prepared medicines. These are the paramparik vaidyas, as are called, and there are about 1 million. So there are about 600,000 villages in India. So you could say about 3 vaidyas, paramparik vaidyas, not Ayurveda vaidyas. They are codified, right? So these are healers, folk healers, for every 2 villages. So 1.5 healer about 2 villages. They still exist, right? And about 40 million rural households. That's nearly half of India's population. If you look at 5 persons per household, right? Using herbs for healthcare, right? I know many of us also have been using that, especially after COVID-19. The sales of ashwagandha and other such botanicals really increased dramatically, right? And there's a good healthy industry as well, manufacturing units, about 10,000 or so now, licensed to prepare herbal formulations for different streams, right? Actually, if you look at all the documentation, and we've been working on that documentation, and now that's been taken over by the TKDL, right? This is the Traditional Knowledge Digital Library by the CSIR Lab of India. And they have documented now more than 3 lakh herbal formulations, right? Which have been listed in the various books, the Siddha, Unani, Swarikpa, Ayurveda, etc., over 3,000 years. So there is a lot of knowledge getting into formulation science now, right? How do you pair these things together? What conditions to use? Which season to use, right? What personalization of medicine. So there's a lot of knowledge around that as well, right? Total trade of about 5 lakh metric tons, split between domestic herbal usage, right? Raw drugs, and then some wastage as well. Exports have more than doubled over the last decade or so. So there's a growing demand outside around botanicals, herbal medicines, and a few tea companies as well. Pakka Teas and others are blending many of these botanicals and buying these botanicals and blending them with tea and creating tea and botanical blends, right? Of course, the big ones in India are the aloe, the amla or amblika, the plantago, the chebula, right? The main buyers being, of course, Ayurveda industry, right? Going into various formulations. The herbal extracts industry. Herbal extracts are easier to export. There are no issues of microbial load, etc. You have better specification, better authentication. And then, of course, I mentioned the herbal infusion industry. This is small, but has potential and may interest people in this room as well. So what are the challenges, right, that this botanicals industry faces, right? And are those some challenges that tea industry may have expertise to tackle, right? Is a question that we started off when we looked at this research. So this was kind of the background as to what is available there. And so, of course, the challenges are in terms of authenticity, purity. Right? We mentioned a lot of these are gathered. When you're gathering from roadside and bringing them to mandis, right? From wastelands and bringing them to mandis, from forests when you're bringing to mandis, then of course you're not really plucking one thing. Along with what you want, there are other things which come in, right? And so there are challenges of purity and authenticity, which are limiting the industry, which are hampering the industry. There are challenges of quality and cleanliness. And quality, we spoke about the whole AI presentation, is something that could really help in looking at the quality of these ingredients. But quality also includes things like microbial load. One reason why many of the consignments of botanicals get rejected when they're exported is because of the microbial load they carry, because of the way that they are harvested, etc., because the way these things are grown, right? Many of them are very small plants growing very near to the earth. And so the whole plucking practices, harvest practices, growing practices need to be looked at, right? The post-harvest processing of these, drying of these into is another challenge. And of course, there are marker compounds which are not available for most of these plants. The availability is another issue because many of these plants, 1,000 plants which are traded, are now endangered, right? Because of overgathering, right? And so that's an issue that there are restrictions, right? They've been endangered, they are threatened, right? The grading and post-harvest operations are not great, right? Something that tea industry is actually very familiar with, but doesn't exist to that level, to that quality in industries outside of tea, right? The transparency of source is not there. Where is it exactly coming from? And scale, right? If you're looking at relying on gatherers bringing 10 kgs of a basket, right? There's many of these things many of these botanicals do not have scale as a result of that. Yeah. So plantation industry has many strengths if you look at the challenges. So plantation industries have many strengths around these things, right? They are experts at agronomy at scale, right? Nurseries, planting materials, fertilization, pruning, harvest, right? How to get quality yield, maximum yield, right? That understanding is inherent in a industry which is now starting at, you could say, 1838, 39 is when the first consignment of tea was shipped from Assam to UK. So it's nearing 200 years of expertise which has been built, right, in this industry. And but this expertise has not yet gone out of the industry to many of the botanicals, world. So that's an opportunity. Similarly, post-harvest, right? Pretty much the model of tea industry, coffee industry, maybe also very similarly, but tea more so. You have the plantation and you have the factory and you have a captive plantation, right? So the post-harvest, that realization that post-harvest processing is extremely important, and therefore having the factory right in the garden is extremely critical, which is what has contributed to success of the tea industry globally, right? Because that has been the single biggest reason for getting to the quality, right? To ensuring the right quality, right? And consistency. So that simple transformations, plus the post-harvest processing, the other thing which is unique is that these simple transformations, right, of fermentation that we call, or maybe oxidation is a better word, whether in tea or in coffee, right? The industries have mastered those simple transformations and can do it without the need of an HPLC or an LCMS, etc., day in, day out, being able to control 4 molecules called catechins, 4 different catechins, being changed into about 30,000 different compounds, right? And with so much of consistency without any instrumental measure. So that has come through by designing the equipment, by ensuring practices, right? So a lot has gone into that. So that comes by nature in the industries, in the plantation industries like tea and coffee, right? And they can be of great help to the medicinal industry as well. The herbal industry, so therefore, can the improved quality, cleanliness, sorting, authenticity, these can certainly be the other value add-ons, right? Besides, at scale, agronomy at scale, and the post-harvest process, they will lead to these advantages, right? And if these are there, there are companies which are, at least what we have spoken to once this partnership started, we felt we should start looking at some of the buyers and talking to them, whether this made sense to them as well. And whoever we spoke to, OmniActive is there, Herb Artisan is there, Natural Remedies is there, Sammy Labs is there, everybody felt that, hey, if this happens, it will be a game changer for the botanical industry in India, right? Because all of them are trying to backward integrate, but that's not their normal business, right? The normal business is actually starting with extracts and finding their customers from there on, right? So what could be the further value add-ons? And this is a number that I got from one of the companies that we contacted, right? They said, look, the additional value could be chemistry-guided, right? Plantations, value that can be generated, which is looking at elite species, right? Which are there. Today when we are gathering, things are there and we are gathering them. But there is a huge opportunity which sits with the elite species. And these are limited in availability, right? Whereas the demand is there. And you can see the value from, these are marker-led, right? Compounds, and similarly value could be created with the print apps, the instrument that Dr. Lai just spoke about. But you can see that at least a 50% and maybe almost like doubling, like in the case of Ashwagandha, going from 175 to 300 plus, right? So there is a scope of that which can only come if these become plantation industries as opposed to the way the industry is running as of today, right? And then growing differently, right? There is a growing need, a growing value of if we could source many of these botanicals, especially from the export market, this is not probably relevant from an Indian perspective, is that the value significantly changes, right? And it doubles. A 300 rupee thing, an elite species can become 600 if it's coming from a ecosystem which is a regenerative ecosystem, right? And gardens, while not necessarily regenerative as of today, only a few gardens are probably operating in a regenerative, but they do come with a image of, when you look at a garden and you look at a tea garden or a coffee, the forest cover coffee gardens of India versus where are the botanicals coming from, right? Tea gardens are always publicized, right? You will have it on the pack of a tea, you have a tea garden and you feel this is natural, etc. You can't put a picture of where I'm growing an Ayurvedic botanical on the cover of, right? Or a tea or a Ayurvedic processing factory on the cover and expect people to buy, right? So tea industry, coffee industry have somehow, maybe they're not exploiting it well enough, but the places where they come from, and I'm telling from my personal example, I never used to drink tea till I visited a tea garden, right? The tea garden visit makes you fall in love with tea, right? And you want to drink it. But is there an opportunity for that with respect to these botanicals? Could we create a sourcing story, right, which talks about the beauty of where they are coming from, right? That's the holistic health, right? It's not just what I'm getting in a cup, but where is it getting, now how does the place where it's growing look like? Does that place look healthy, right? If that place looks healthy, maybe I look healthy. So those are kind of stories that plantation industry can really look at, right? And when we speak about, when we talk to the global markets as to where do they think consumers are shifting towards, these are some places where the consumers are shifting towards. So of course, there are other benefits that probably plantation industry would have even a better, a longer list, but there's a secondary income because many of these things don't need to, can grow along with the tea plantations. There's a better utilization of labor through the seasons if you select for the right things where tea production is lighter, at what time do which of these 1000 botanicals are the right ones to suit in the tea cycle or the coffee cycle, right? Soil regeneration can happen, biodiversity is always a plus plus, right? And so going from a monoculture to multiculture can happen, right? So just talking one slide about the university where I come from and the knowledge base that we've been working on over the last 30 years, right? So as I mentioned, we have a database of about 6,500 species, right, of medicinal plants, curated from authentic texts. So we have all of them referenced. 4,000 of those 6,500 species, there are scientists who have traveled all across India, gathered specimens, and we have a very wide herbarium, right, where we have actual parts, the bark, the leaf, the root, the stem, whatever part is used for the medicine. So we have those in our herbarium sheets. We have a living collection in our own garden, university garden. 1,500 species are actually growing. Yeah, there. Bangalore is gifted with a weather where a lot of different things can grow from different biogeographic regions. So 1,500 or so grow on our campus. We have a nursery where 650 of those species can actually be upscaled and we can provide material. We also have moved into a food plants database. So looking at which of these species can be used as wild edibles, because wild edibles is another theme which is coming up to bring diversity to our food plates from a microbiome health perspective. And we have a pilot food forest, a very small 3,000 square foot area where we are growing 80 plus species in that little, garden. Yeah. So now coming to a UPASI pilot that we started, right, just 3 months ago. Yeah. So we were given some GPS locations of. So we were given some GPS locations, right, by UPASI, and said, okay, these are the latitudes, longitudes, this is the altitude. What will be out of those 1,000 species, which are the ones? Give us, say, top 10. And there were certain criteria which were set, like they should be high volume traded, various criteria to be set. So we went around looking at creating a long list of what all from our database, because our database also has where do these things grow, what kind of soil do they like, how much water do they like, etc. So we created a list of botanicals, a long list as we call, right, from this. We had the geolocation, we took the agroclimate, agroecology parameters, we went to our database, which we call Indian Medicinal Plant Database, or IMPLAD, and then we coupled that with the BSI Flora's databases, right, which are the Botanical Survey of India's databases for each, which are state-wise and give us drill down to district level information, right? And we pulled that entire information together along with the status, the RET, the threat status, the habitat, the propagation, the economics, the trade value, and identified a few plants, right? So this is how we went about going around, created long lists of plants. This is an Excel sheet, just a snapshot from an Excel sheet that we have. And we identified for the Nilgiris regions about 295 total plants, from Coimbatore region 606, Chikmagalur, the GPS location 583, and so on. The last number shows the total number of plants we identified from our database that could be grown in those locations. And where are they coming from, whether used in Ayurveda or Siddha, etc., that's kind of mapped, right, in this chart, right? And then looking at the really high volume traded, right, and the volumes traded are given in the column, we then had mapped the top few which fit in there. And from this we made a selection, and there are 23 of these plants which are right now growing in, I think, 4 pilots, one in UPASI, one in Valparai, and 2 in private gardens, right? So we're looking at, they just got planted 2 months ago, and we'll be following them to look at how they take on, what are the kind of practices, the package of practices we need to develop in the plantations. So it's a 2-3 year pilot which will go on, right? But we also, so that's 23. But for the purpose of this meeting, then we decided that, hey, this is a tea and coffee industry. So let's look at how some of these, out of the 50 or so that we had identified the long list, which ones would actually get blended with tea, right? And see, can we taste them with tea and create interesting blends, right? So our first exercise we have done, we shortlisted together with Pubati Raj and his team, TRF, with Victor, 10 of these plants that we selected that were part of the pilot, right? And we did some tasting exercises with these, had criteria, created 60 blends. These blends were essentially only one ingredient and a tea at a time, right? Finally, if we start looking at commercial, there will be more complex blends. But it's just to get a sense of the tasting, right? And they were chosen for various reasons. We went through an exercise of what particles how should we grind it down, what particles to select, where would a blend work, right? So that there'll be no segregation, had to look at densities, etc. And then make the teas, right? And we evaluated a range of 2 to 5% range. And you can taste some of those teas outside. There is a stall where there are 5 teas made from this with black tea, CTC, and 5 from Orthodox, right? And please do taste, take a few minutes and do taste them and give your feedback, right? We collected our own when we were tasting. We had our own notes. When we had the herbs, we made infusions on their own, separately, without any tea in there, and created notes. What was the color of the infusion, the aroma, flavor, the taste, the aftertaste, the mouth feel, right? Just to get a sense as to which ones would not change, if they were neutral in color, which means they would not change the color of the tea, right? If they were neutral in taste, they would not change the taste of the tea. So you could add them at a higher level for efficacy, etc., right? And so this matrix was created, and then a similar one for the blends that we created, right? Along with all this information, we also have a lot of Ayurvedic parameters for these ingredients. I have just 2 more slides, so 2 minutes and I'll be done, right? And so Ayurveda looks at, very interestingly, its own vocabulary of trying to understand the biology of these ingredients, right? And what we call as the rasa. The rasa is an in-mouth experience, but what is interesting is that over thousands of years, that in-mouth experiences has been correlated with health benefits, right? What will a sweet taste do? What will a sar rasa do, an amla rasa do? What will a tikta rasa do, a kattu rasa do? And interestingly, kashaya or astringency, which is what we associate with tea. Actually, we associate madhur, amla, bitter tikta, and kashaya. 4 ingredients, 4 rasas are there in tea out of the 6. And very few ingredients in nature which have multiple rasas in there. And how they impact the 3 basic dimensions of health, vata, pitta, and kapha, right? And there are algorithms to do that, right? And then you could play around with creating a blend and see how you can increase or reduce on any one dimension. And we have that kind of an information for all of these plants, right? The information from the Ayurveda perspective, the rasa map, the biophysical and the biochemistry map from an Ayurveda perspective, right? And also the modern chemistry, where we have the antioxidant map, the polyphenol map, and the whole metabolome, right? 2,000 molecules here in amla itself, right? And being able to connect each of those molecules with the network pharmacology as to which molecule interacts with which of the 20,000 proteins that we have in our body, and therefore what pathway do they affect, right? The network pharmacology. So bringing the whole power of omic science and Ayurveda and integrating it together, and that's where we will start moving these blends toward as we move forward. Yeah. So, that's just, I've mentioned where the status is, and hopefully as the pilot progresses, there'll be more news. But with that, I'm happy to answer any questions if you have. Yeah.
Thank you, Dr. Gurmeet. I think we have a stall out here where these teas are available for tasting, and I would, because we're running out of time, so I would suggest you all reach out there. Oh, one question, huh? Okay, so ED would like to ask a question.
Myself, Muthu Kumar. I am the Executive Director, South India Tea Board. Actually, now the blending is happening a lot of in tea industry.
Yeah.
This is now you are talking about natural infusion, okay? Suppose maybe ashwagandha or tulsi or something. Suppose this natural infusion is one hand, other hand is the similar natural identical infusion synthesized by the chemically. Okay, so both are same, physically or chemically. What is the reaction in the human body? Then what is the second, what is the cost effectiveness about the natural infusion and natural identical infusion synthesized by the chemical? What is the difference of both physically or chemical, or what is the reaction in the human body? What is the cost effectiveness?
See, when we talk about getting nature identical, right? Largely volatile molecules has become popular for nature identical. Non-volatiles are not that popular. We have just a few molecules that know vanillin as opposed to vanilla extract. Vanilla is very complex. The price is very high. Vanillin is cheaper, right? The price difference will at least be double, if not 5 times in many cases, right? That's okay for a sensorial maybe, right? But if you are trying to play in the whole area of infusions of goodness, as we said, then you need to look at the whole complexity, why, right, the whole extract was used, why the infusion was used as opposed to a certain molecule which is nature identical. There's no nature identical extract. There's a nature identical molecule, right, which smells like banana, which smells like vanilla, right? But there's no extract of banana. That is not nature identical, is not possible. In my last slide, I just showed amla, right? 2,000 molecules, right, that we've identified. In tea, when we work, 30,000 molecules we identified, right? There's no way to make a nature identical tea, right? 1 or 2 molecules, I can take theanine, I can put a catechin, I can put one theophlavin from somewhere and say this looks like tea, feels like tea, and maybe there's a business model to there. But if you're looking for goodness, the goodness comes from the complex mix, right? And that is required, because we do see from our study that when we have the whole mix and we throw that whole mix into our algorithm to see where all it interacts in the body, and we have platforms, just like the AI platform, we also have similar platforms where we have the 2,000, 20,000 proteins, the 20,000 genes of the human body, and we can take our botanicals, our extracts, the molecules we can categorize through metabolomics, and we feed it into the system and tell us where all will it, which all proteins, human proteins does it interact with, which all genes will it interact with. It comes with, these are the interactions, level 1, level 2, level 3. Then we can cluster them together because we have some understanding of these proteins and genes as to what body function, what disease function do they cluster towards. These are 20 interactions, they are all in the metabolic health cluster and therefore can impact diabetes or cardiovascular health. And then we start getting a sense as to why they were used. Then we take that information and integrate it and check against the traditional knowledge information as to what were they getting used. If it gets corroborated, that's a plus. If it doesn't, then there's a new insight, right, which is generated, a new hypothesis which is generated. So it's a very fascinating cutting edge area, right, which is moving on. Yeah.
We are facing a serious problem of pyrolysis alkalides in our exports. By mixing these compounds or by growing, will it create any problem for our pyrolysis alkalide content in our teas?
You're saying when you combine them in tea and sell as a blend?
Even, growing also some
in the growing itself?
Yes.
Yeah, I mean, yeah, any problem we'll have to challenge. That's a challenge.
No, but
That's a major problem for our
no,
exports.
I think pyrolysis in alcohol is one of the screening parameters. So these are screened for that. Only then it passes. So it was mentioned in his presentation that's one of the parameters it's screened for.
That is, some of that helps, what you also that contains very high amount of pyrolysis alkalides.
Yeah. So
But, even our weeds, from the tea fields, even after controlling all the weeds, we are getting very high level of PA. But by growing this, will it have any impact?
No. So one, we use that as a screen because that was told to us by UPASI to use that as a screen. So the plants we selected were selected after whatever passed through that screen. But besides this, there may be other such problems which may emerge, which we'll have to tackle, right?
But
So our selection
any
will be
data
based.
for PA content of all these herbs? PA content of all these herbs, you have any data?
I don't have any data. This data was taken from literature. We've not done any measurements. Right?
So while please discuss offline, I think Dr. Victor also has this information because we're working together in that.
Yeah.
Anyway, thank you Dr. Gurmeet for that excellent presentation. I would also like to mention here that this initiative, this is both in terms of crop diversification and value addition in one go. It was initiated by our past chairman, Mr. M.P. Cherian, who continues to spearhead this as chair of the Research Collaboration Committee at UPASI. So now I'd like to call on the Vice President to present a memento to Dr. Gurmeet. And Mr. Matthew Abraham, our Vice President, will also propose the vote of thanks for our session now.
Mr. Sridharan, President UPASI, Dr. Arvind, Dr. Amitava Akuli, Dr. Gurmeet Singh, Mr. GVK Naidu, Mr. Alan Lai, and distinguished guests, ladies and gentlemen, a very good afternoon to one and all. I have the pleasant task of delivering the vote of thanks. As we conclude today's technical session, we had the opportunity to hear several insightful papers covering a range of topics highly relevant to the challenges we face today. The plantation sector is grappling with unprecedented global pressures alongside rising production costs that hinder our global competitiveness. The discussions held here today will certainly aid us in developing more effective strategies to address some of the critical issues facing this vital agro industry. I would now like to extend my sincere thanks to Dr. P.V. Arvind, Professor and Chair of Energy Conversion at the University of Groningen, for his outstanding presentation of Going Carbon Negative Options for the Plantation Sector. A heartfelt thanks to Dr. Amitava Akuli, Associate Director R&D at SEDAC, Calcutta, for his excellent presentation on AI-based aerial imaging solutions for detecting pest attacks in tea. I will also express my gratitude to GVK Naidu, Director Westphalia Fruit India, for his insightful presentation on the prospects and challenges of avocado planting in South India. Thank you to Mr. Alan Lai, Founder and CEO of Profile Print, Singapore, for his engaging talk on quality profiling using AI. A special thanks to Dr. Gurmeet Singh, Professor and Dean of Research and Outreach at TDU Bangalore, for his excellent presentation on the blending of botanicals, opportunity for the tea sector. I would also like to thank the media, both print and visual, for covering this session. A big thank you to Messrs. Famedo Crop Science Private Limited for sponsoring the folders, and to the Tea Board and Coffee Board for providing tea and coffee to our delegates. I also extend my gratitude to Messrs. Chennai Metex Lab Private Limited for sponsoring the program booklet for our annual conference. Thank you to Messrs. KDHP Company Private Limited and Messrs. Tata Coffee Limited for sponsoring today's lunch. I also thank Messrs. ABT Company Limited, Harrison's Malayalam Limited, Pari Agro Industries Limited, and Sri Vasuprada Plantations Limited for sponsoring tomorrow's lunch. Finally, a warm thank you to all our distinguished guests and participants for your attention and for joining us today. Your presence is greatly appreciated. Thank you all.